Hello, in today's lesson we will discuss motion of objects. We live in a world of motion, a universe of motion. Everything is in a continuous state of motion. Now sometimes you say, but I'm sitting quietly here, I'm not moving. Well, ask somebody on the moon. Well, or ask somebody in Mars. They will see you moving rapidly. Well, motion is the common phenomenon in nature. We see moving objects all around us. And we think, no, we know about motion. Do you really know what motion means? Well, consider this example. A football player is running with the ball. Now my question is the ball moving? Tell me, is the ball moving? Well, it depends on who looks at the ball. You see, the football player says, well, I'm running with the ball, is that right? I'm running with the ball and I see the ball always with me. The ball is not moving, but so the runner looks at the ball and says the ball is not moving. But a spectator looks at the ball and says, I see the ball moving. So an object is in motion or not depends on who looks at it from where. So sitting on your chair, you say that you are not moving. But a person on Mars see you moving around the sun. Also, the earth is rotating. We got many different kinds of motion. Is that right? So motion is not all that simple. Now consider the following example and see if you can answer it. I'm not going to answer it. I'm going to simply throw it at you. If you want to respond to that question, get back to me. Now, if I am in a parked car with the windows rolled up and there is a fly hovering in the air next to me, if the car accelerates rapidly from rest, is it possible that the fly will hit the rear window, or will it continue to hover next to my ear? Have you experienced something like that? Think about this. And if you have an answer, let me know. Email me and discuss it with me. Alright? Now to answer questions of this type, you need to understand the meaning of relative motion. What does relative motion mean? All motion are relative. It depends on who looks at what from where. Now here is another example. Now imagine you are in a car with your friend. You look at each other, you see your friend sitting next to you and say, well, are you moving? No, I always look right and see my friend there. The friend looks left and see me there. You are not moving. But a friend standing on the pavement see you both moving and say, hello, where are you going? Is that right? So when the friend looks at you, the two of you are moving. So whether you are moving or not depends on who is making the decision and from where is that decision made. And that person's movement. We in the car could just as well say that we were stopped and then the whole world is moving. Have you ever noticed that when you are on a traffic light stopped, well, if a big truck is rolling next to you and you feel that you are moving, I have experienced that several times. So motion is relative. Now, let's access a website and look at the meaning of relative motion if we can. Give me a second. Now watch this illustration. What do you see here? You see, this is a river flowing down. There are boats in the river. There is a man on the shore of the river. Well, now this is the river shore. Now where are you looking from? Now let me reset that and start all over. Alright? Alright, let's start it. Now what do you see when you start? Can you explain what you see? Now this is the river shore. This is a man walking down the shore of the river. Now this yellow tells you the river is flowing downstream and the boats are going downstream. There's a raft on the river. There's a man standing on that raft. Alright, there are many things in here, and let's now look, see, if something is moving or not depends on who looks at it from where. Now we are looking from outside the classroom or in your room. We see the river moving down, the boats moving down. You see the river shore is stationary, is that right? Okay, now I can take the mouse and watch me when I take the mouse and keep it in the river. You see, now I'm looking from the mirror. I'm sorry, I'm looking from the river. So I can place the mouse so that I can be there. Now I am in the river. You see, I see the river bank moving backward. You see that? What do I see the river doing? I'm in the river. I don't see the river moving. See that? The river is at rest when I look at it, because I'm in the river. You see, I'm standing in a room. If the room is moving, is there any way I can know of it? If you are in a plane, if there are no clouds outside, all the windows closed, is there any way you know that the plane is moving? No. So you are in the river, you don't see the river moving. You see the river bank moving backward. The man on the river bank again moving to the left. Now when we looked at from outside, the man was going to the right. Is that right? Okay, look at the raft in the river. That raft is at rest now because it was floating in the river. When I look at it from there, it is now at rest. And there is a creature moving back and forth on it. Okay, tell me. If I now go on to the boat, what will you see? The boats are now going down. I'm going to go into the boat. Alright, take my mouse and stand in the boat. I'm now looking from the boat. What do I see? I see the river flowing backward. The river bank is going in a faster rate backward. The man is traveling to the west very fast backward. And you see the raft is going backward. You see, the motion is completely changed. So when you change the place from where you look, all motion seems to be different. Alright, let's go. Let me go and put my mouse on the man. That means the man is now the observer. This man is now me. Alright, you can see I am at rest now. And what do I see? I see the river bank moving backward, and I see the river going down and everything else. Okay, now if I stand on the river bank, there I'm standing on the river bank, I see the river bank not moving, but the river is flowing down, the man is walking east, you see, everything is normal. The raft is going down, and the little creature is happily moving back and forth. Now look at the complexity of motion. I would like you to play with this for a while and learn more about what is called relative motion. All motion is relative. It depends on where you look from and who looks at motion. Is that right? I hope you understand a bit about relative motion from here. Alright. Now let's talk about frame of reference. What is a frame of reference? Now these examples I showed you suggest that motion is relative. It depends on who the observer is and where the observer is stationed. Is that right? A frame where the observer is stationed is called a frame of reference. When the observer is on the river bank is the frame of reference. When the observer is in the river is the frame of reference. And all your observations are made from that frame of reference. So in the frame of reference of the river bank, the person is moving to the right. You agree with me? Right. In the frame of reference of the river, when you go into the river and look at the person, you see him moving to the left. Now, what is the motion of the river when observed from the boat? When observed from the boat, you saw the river was going backward. So in the frame of reference of the boat, the person in the riverbank is moving west. But the person on the riverbank says he is walking east. So the two people, when you are observing from the boat in the river, you see the person on the riverbank moving west. But the person says, no, I'm walking east. See, look at the complexity of motion here. An object is at rest or is in a state of motion with respect to a frame of reference. Only with respect to a frame of reference can you say if an object is at rest or moving. Now I can say this block of wood is at rest when I look at it from the frame of reference of this classroom. The camera in front of me is at rest in the frame of reference of the classroom. But if the frame of reference is Mars, the camera is moving, I am moving, and so on. So an object observed to be at rest in one frame of reference will be moving when observed from another frame of reference. Okay, once you understand the meaning of frame of reference and relative motion, let's talk about measuring motion. You see, we do measure motion every time. You get ticketed if you go faster than you are allowed to. So somebody is measuring your motion. Watch out. You are always being measured. That is part of our life. Alright, motion of an object involves two fundamental quantities. What are they? What are the two fundamental quantities that are involved in the motion of an object? Well, the moving object changes its position. So position is one quantity that changes. Is that right? Alright. The change in position happens in a time. So you can see we got two variables here. What are the variables? The position of the object is changing. The time is changing. So those are the two variables in measuring motion. The change of position of the moving object is called its displacement. You see, when an object changes its position, look at this object here. The object is here when you look at it first, and its position is changed to here after a certain time. We say the object is displaced. The change in position is called the displacement of the object. The object is displaced. So the change in position of a moving object is called its displacement. Now how do you find the displacement? If you know the initial position and you know the final position, you can say the final position minus the initial position is the displacement of the object. All right? Okay. Now the rate at which the position changes can be obtained by dividing the displacement by the time interval. Well, let's talk about the displacement of an object. Now here I have the object initially here, and after a certain amount of time the object is here. It got displaced. What is the displacement? If this position is called x1, is it alright to call it x1, that position? And this position is called x2. Then the displacement or the change in position is x2 minus x1. And this change happened in a certain amount of time. So if you divide this change in position by the time, you get the rate at which the position is changed. You see, that's an important quantity in studying motion. So the rate at which the position of an object change can be obtained by dividing the change in position, the displacement, by the change in time. And this rate, now you remember we talked about the slope of a graph, is the rate of change. The rate at which the position changes of a moving object is called its average velocity. A moving object has an average velocity. And how do you define average velocity? Average velocity is defined as the rate at which the object changes its position. The rate of change in position. In other words, the change in position divided by the change in time is a measure of the average velocity. Isn't that simple? Yes. So average velocity is the rate of change of position. Average velocity is the rate of change of position of a moving object. Now consider a car at position x1. Now this is my, let's do a Cartesian coordinate to locate the position. Now this is the origin, this is the x-axis, and we're going to let a car move along the x-axis. So we will measure the position in terms of x. So look at the car here, it is at a position x1. That x1 can be 2 meter, 3 meter, or any distance. Let that position be called x1. Now it moves to position x2 over here. Now the time taken for that car to move from x1 to x2, we're going to call it delta t. You are familiar with that. Remember, delta t does not mean delta multiplied by t. The delta t is a representation we use to represent the change in the time. Is that right? So the position of the car changed from an initial position x1 to a position x2 in a time interval delta t. Now what is the change in position of the car? The change in position is the final position minus the initial position. We call it x2 minus x1. And so, how can I write the average velocity of the car now? Average velocity, I'm going to say V average. Don't worry about that. You simply call it V. Is change in position x2 minus x1 divided by the change in time, right? Alright, now I can therefore say average speed. Now this time, instead of velocity, I'm going to use the word speed. And in this course, we are going to use velocity and speed to mean the same thing, although they are not the same thing. When you talk about the velocity, you also talk about the direction of motion of the car. Whereas when you talk about the speed, you don't talk about the direction. So if you want to calculate the average speed, what all you need to do is obtain the distance traveled by the car. This is the distance traveled by the car, and divide that by the time. That will give you the average speed. Now, distance is measured in meters and the time is measured in seconds, and therefore what is the unit for measuring average speed? Can you tell me? Distance is measured in meters, time is measured in seconds. So what is the unit for measuring speed? Speed is measured in meter per second. Let me go to my whiteboard and show you that. So, distance is measured in meter, time is measured in second, therefore speed is measured in meter per second. And how do you calculate speed? If I take you back to this equation, the change in position. Can I write x2 minus x1 as delta x? Would you allow me to do that? Yes. And so I can say the average speed is the distance is the change in position. x2 minus x1. You see the change in position divided by the change in time. That is a measure of the average speed. Okay, and the unit of that average speed is meter per second. Now, here I have a car moving. You can see as the car moves, it has to stop at various places. Is that right? Now, wherever it has a red light, it stops. So, if it starts from here, and after a certain time it comes here, you can see the distance is measured in kilometer and the time is measured in hour. Can you calculate the average speed of this car? Alright, let's try it again. Alright, it travels a distance of 5 kilometers in what time? What is the time? Can you tell me? Time is 0.2 hours. So, let's calculate the average speed. Tell me, what is delta x equal to? What does delta x stand for? Delta x is the change in position. It is 5 minus 0. So, delta x is 5 kilometers. We have the distance in kilometers. You see, a car travels a very long distance in a certain time. So delta x is 5 kilometers. What is delta t? What is the time taken for that car to come up to here? It was actually 0.2 hours. Is that right? I stopped the animation. But when the car comes here, that time will read 0.2 hours. So that will be 0.2 hours. Therefore, average speed equal to the change in position divided by the change in time. The average velocity or average speed is the change in position, which is 5 minus 0, that is 5 kilometers, and change in time is 0.2 hour. So that will be 0.5 kilometer divided by, I'm going to write it again. It is not 0.5 kilometer, it is 5 kilometer divided by 0.2 hour. Can anybody tell me what is the value of 5 kilometer divided by 0.2 hour? Can you do that quickly? Well, you know, if you want to divide 5 by 0.2, make 0.2 a whole number by moving the decimal one place to the right. When you do that, on the right, on the numerator also you do that. So that will become 50 kilometer divided by 2 hours. You see, 5 kilometer divided by 0.2 hour is the same as 50 kilometer divided by 2 hours. I hope you understand that. And so the average speed of our car is 25 kilometer per hour. Look at the way I write kilometer per hour. That is the average speed of this car. Alright, let's make it go again. You can see it travels 5 kilometer in 0.2 hours. Alright, now what is the difference between velocity and speed? I told you the difference. The difference is velocity of a moving object has a direction, whereas speed does not have a mention of direction. Velocity of a moving object refers its speed in a given direction. When you talk about a car moving at 25 km per hour due east, you are talking about its speed and direction, and that becomes then the velocity. While velocity has a direction, speed has no direction. When you talk about the speed of a car, you simply say how fast it is going. But when you talk about the velocity of a car, you not only talk about how fast it is going, but in what direction it is going. You see that? That is velocity. So you must understand the difference between velocity and speed. For motion along a straight line, we will, as far as we are concerned in this course, we will use both to mean the same thing. Alright? So when I use velocity or speed, it means the same thing for us. Alright, let's do a very simple calculation. I know most of you don't like calculations, but a simple science course must sharpen your thinking. Is that right? That's important for you. What is the average speed of a car that travels 12 kilometers in 8 minutes? Well, I want you to find the value of the speed in meter per second. So you must say distance is 12 kilometer. And you know, 1 kilometer contains 1,000 meter. So 12 kilometer is 12,000 meter. And time has to be written in minutes. 8 minutes contains how many seconds? 8 multiplied by 60 is 480 seconds. So your distance delta x, is that right? I want you to practice that more and more. The change in position, your delta x is 12,000 meter, and the time delta t is 480 seconds. Therefore, average speed is delta x divided by delta t, which is 12,000 meter divided by 480 seconds. Can you tell me what that is? Alright? Calculate that on your own. So average speed is distance divided by time. Delta x divided by delta t. That is 12,000 meters divided by 480 seconds, and that is 25 meters per second is the average speed of that car. Okay? How about another one? A car travels at an average speed of 16 meters per second for 1 hour 20 minutes. What is the distance traveled by the car? Alright, can you write a relation between speed, distance and time? Well, this is what we know. Average speed is 16 meters per second and the time is 1 hour 20 minutes. Well, this time needs to be written in seconds. Can you tell me how many seconds are in 1 hour 20 minutes? Well, 1 hour 20 minutes Look at this. I'm going to show you how to get the number of seconds there. 1 hour contains 60 times 60 seconds. And then you got to add to that the number of hours in 20 minutes. 20 minutes contains 20 times 60. You see? 1 hour and 20 minutes. 1 hour contains 60 times 60 seconds. Plus 20 minutes contains 20 times 60. And that should give you 4,800 seconds. Okay. What are we supposed to find? We need to find the distance. Isn't the distance equal to average speed multiplied by time? Yes. You can see distance equal to average speed multiplied by time, which is the same as average speed equal to distance divided by time. So to find the distance, we multiply this average speed by the time. So that will be 16 meters per second multiplied by 4,800 seconds. And that will be 76,800 meters. Can you write this in kilometers? 76,800 meter is how many kilometers? Well, all you need to do is divide it by 1,000 or move the decimal 3 places to the left. Look at that. I start with this one, 1, 2, 3, and put the decimal here. That will be 76.8 kilometer. That is the distance traveled. Well, you must know these very simple concepts. All right. Now, we talked about the slope of a graph. Now, in studying motion, if you draw the graph of the position of an object against time and measure the slope of a graph, that will give you the rate of change of position. So the slope is a measure of the rate of change. So slope of a graph is a measure of the rate of change. We did that earlier. You are familiar with the equation y equal to mx. We talked about it. Is that right? Now, what does m represent in this equation? You know it. M represents the slope, the rate of change of y with respect to x. Now, x is called the independent variable and y is called the dependent variable, and m is the constant which represents the slope of the graph when you have the equation y equal to mx. So you draw a graph of y on the vertical axis, x on the horizontal axis. The slope of that graph will be m. And what does slope represent? It represents the rate of change of y with x. Now, consider a moving car in the x direction. If a car moves in the x direction, an equation containing its position x. So this time, the distance covered by the car is going to be represented by x. And the time is represented by t. Now, if the average speed is v, can you write an equation connecting x, t, and v? Well, you see, we're going to have a car traveling in the x direction. Now, if the car is here now, after a little while the car is there. What is the equation for the distance? We did that in the last slide. Distance equal to average speed multiplied by time. Is that right? Yes. And distance I'm going to call x. That's our distance. So if this distance is called x, we call it x because the car is moving along the x-axis. So I can write x equal to v multiplied by t. Look at that. The distance traveled by the car is the average velocity multiplied by time. And if you look at this, x is a variable, t is a variable, and v, the average speed, is a constant. Alright, let's write down that one more time. Now we can write x equal to vt as that equation. Now, a graph therefore, look at this. Can you compare y equal to mx and x equal to vt? This x is in the position of y and this t is in the position of x. That means if you draw a graph of x on the vertical axis or x on the y-axis, you see we normally call the vertical axis the y-axis. Now this time we're going to represent the x, the distance of the car on that y-axis, and the time on the x-axis. If you now draw a graph of x on the vertical axis, the y-axis, and time t on the horizontal axis, what will be the slope of that graph? The slope of that graph will be this v, the average speed. That is the rate of change of distance with time. Is that right? Yes. So I have got the equation displaced slightly. I meant to write that equation. Now let me write that down for you here. This equation, I want to write it as y equal to mx. In other words, x is in the position of y, t is in the position, you see, x is in the position of y, t is in the position of x, and v is in the position of m. There you are. There you are. So that means if I now draw a graph of this x on the y-axis and this t on the x-axis, the graph will be a straight line. You see here again, y equal to mx means a graph of y against x will be a straight line and the slope will be m. In our equation x equal to vt, x is in the position of y, t is in the position of x. So if you draw a graph of x on the vertical axis, on the y-axis, and this t on the horizontal axis, the graph will be a straight line. The slope of that graph will give you the average speed. That is what it means. Okay, let's move on. Alright, let's do a lab. Measuring the average speed. Measuring the average speed. To measure the average speed, we measure the distance traveled by a car and measure the time. Now, here, the table shows the distance traveled by a car and the time of travel. Draw a graph and obtain the average speed of the car. Now look at the table here. It's a very simple table. Position 0, 2, 4, 8, they are all in meters. And these are the time values. Now, can you draw a graph of x versus time t? I'm going to show that to you one more time. And then I will show this to you, and then we will do some measurements. You will take down some values and do the calculations on your own. Alright? I'm going to show this to you. Let me draw that graph for you. Now watch me draw this graph. Well, I'm going to have the vertical axis, the horizontal axis. Tell me what is going to be on the vertical axis. We got two variables. X is the distance and t is the time. So which of these variables is on the vertical axis? It's going to be your x. So look at where I'm writing it. My vertical axis is x in meters. My horizontal axis is time in seconds. Alright, now I need to mark my axis. How do I mark the axis? If I know time is changing from 0 to over 80. So I'm going to go in steps of 10. So see how I'm going to mark my axis. This is t equal to 0. This is t equal to 10, 20. That is 30. This is 40, 50, 60, 70, 80, 90. I've got time. I've got up to 81, so I went in steps of 10. 10, 20, 30, 40, 50. Well, I think I wrote 40 twice. Is that right? So I need to go back and change that. That's 40. Well, that is my 50, 60, 70, 80, and 90. And how do I mark my vertical axis? I have to go up to 18. So what I'm going to do is I'm going to go in steps of 5. 5, 10, 15, 20. Alright. How do we mark these points? When x equal to 0, t is 0, that is the origin. When t equal to 9, that means when t equal to 9, x equal to 2. Now, when t equal to 9, that is my t equal to 9, x equal to 2 will be somewhere there. This is the point, you see. The t value, t equal to 9, x equal to 2 will be that point. Alright, next, t equal to 21, somewhere here, x equal to 4. So, t equal to 21 will be somewhere there, and x equal to 4, this is the point, that will be 21, 4. Okay, next, t equal to 28 and x equal to 8. Is that right? Alright, t equal to 28, this is 20, that is 30, this is 28, and this is 8, that is the point. And the next one is 39. Well, 39 is over here. You watch me now do this. T equal to 39, x equal to 10 is over here. Now, t equal to 53. This is 50. 53 will be somewhere there. And x equal to 12 will be, I hope you're following how I'm marking this. That's the point. Now t equal to 60, that is my t equal to 60. And what is my x value? 14. And 14 is there. I hope you understand that. When t equal to 60, x equal to 14, that is 15. So 14 will be somewhere there. This is my point, t equal to 60, x equal to 15. So I've got that point there. My next one is 73, that is 73, t equal to 73, and x equal to 16. Alright. And finally, t equal to 81, and x equal to 18. That is my point. Now you notice that these points really do not lie on a straight line, but what you need to do is draw the best possible straight line. Use a ruler and draw the best possible straight line so that these points will lie as close to the line as possible. Alright, I'm going to draw that for you. Alright, that is the best possible straight line. Now what you need to do is we need to now measure the slope of this graph. Now how to measure the slope? Take 2 points on the graph. Now let's take 2 points. This is 1 point, and let's take that point or this point. Alright, let's take 2 points. Now this point I'm going to mark it with a big circle. And what is the name of that point? T equal to 39. This point is called, that will be 39, 10. And let's take this point, that will be 73, 16. You see, I'm taking these 2 points to find my slope. I took that point, the t value is 39 and the x value is 10. I took another point. You can take any 2 points, it doesn't matter which you take. Its t value is 73 and the x value is 16. What do I now do? Find the change in the t value. You see, the t value changed from 39 to 73. Find the change in the t value. Alright, so let's do that. Delta t, the change in the t value, is 73 minus 39. Tell me, what is 73 minus 39? Anybody tell me? Got an answer for that? 73 minus 39. Anybody got an answer? Alright. Well, I hope you got the answer. I got it as 34, is that right? 34 seconds. Now, that is the change in the time. Now, what is the change in the value of position, x? Now, here, the distance changed from 10 meter to 16 meter. So the change in the position, delta x equal to 16 minus 10 equal to 6 meter. So you got your delta x equal to, your delta x is 6 meter, delta t is 34 seconds. Therefore, what is your average speed, the slope? I'm going to write over here, watch here. So the slope equal to, the average speed of v is the slope. Is that right? Is the slope, and that is delta x divided by delta t. That is 6 meter divided by 34 seconds. And I want you to calculate that and write it using the unit. So it must look like this. V equal to 6 meter divided by 34 seconds. And what is 6 divided by 34? I can write it as 0.18. 0.18 meter per second is the average speed. Alright? Okay, I want you to do this on your own now. Now, you can hit pause on the video and do this on your own. Make sure that you understand how to mark each of these points. Alright? I'm going to take it out and I'm going to take you to taking measurements and do the experiment all over again. Okay. In the experiment I'm going to do, I'm going to run a car. Well, I have a beautiful car here. I'm going to run it between 2 gates. Now what I have done is, I have kept the two gates at a distance of 20 centimeter. That means the car is going to move a distance of 20 centimeter, and the time taken by the car to move between the gates will be read by this clock. You see the clock here? Now, so it's your job to measure the time. I will run the car and I want you to fill in the values in your table. Now, I'm going to make a small change in the table from what is given here. So try and follow this. Now, what is the first distance I'm going to run? 20 centimeter. Alright, I'm going to use a cart driver. Well, I dropped my car, so give me a second to get settled again. Alright, I'm going to drive the car with this. Can you see this? That's my gun. And I'm going to drive it to a distance of 20 centimeter, and you need to measure the time. Alright, now the distance x is 20 centimeter, and measure the time. Alright, here goes the car. Let's see if the clock works. If it doesn't work, we will do it again. Did the clock work? Yes. So write down that time in seconds. What is the time that you have? The distance is 20 centimeter. So make a table. The table will look like this. Now, make a table there so that you've got the distance x in centimeters, time in seconds. Now, the first distance is 20 centimeter, and what is the time that we got? 0.0265, is that right? Yes. No, that's 0.265. It is 0.265. Alright. Now I'm going to increase the distance to 30 centimeter. What all I need to do is move this gate so that it is at a distance of 30 centimeter. And I'm going to reset the clock. And I want to make sure that the clock works. Okay, and I'm now going to run the car for 30 centimeter, and you've got to measure the time. Alright, I'm going to use the same gun. Alright, measure the time now. Did you get the time? Well, I've got 30 centimeter. And what is the time? Time measured, I think you got 0.31, write it as 0.319. Alright, now I'm going to go to 40 centimeter. I'm going to move the gate so that the distance is now 40 centimeter. Okay. And now I'm going to reset the clock. Okay, and I'm going to drive the car. Okay, now let me load the gun, and I'm going to drive the car, measure the time. There we are. It didn't quite work. I'm going to repeat that. So disregard this time. Alright? I think I need to reset the clock. Now let's reset it and check if it is working. No. So reset it. It's not working. So I need to go back and reset it. Let's see if it can be made to work. It doesn't want to work. Alright, let's drive the car through this 40 centimeter and measure the time. Let me load the gun. And I'm going to drive the car. I hope it goes this time alright. Alright, did you get a time? That will be 0.465. Well, the time is 0.465 seconds. And let's now drive it to 50 centimeter. This time I'm going to drive the car to 50 centimeter. Okay, let me move this out. Give me a second to prepare. Move the gate to 50 centimeter. There we are. Alright, let's drive the car now to 50 centimeter and see what happens now. Alright, I'm now going to run the car and measure the time for 50 centimeter. There we are, let me drive it. Okay. Alright, what's the time that you measured? For 50 centimeter, the time is 0.522. The time is 0.522. And we're going to do only one more so that we get 5 points. We're going to do 60 centimeter now. And let's see. The 60 centimeter will be over here. So the car is now going to be driven through 60 centimeter. Measure the time. Alright. Let's see. Let me reset the clock. Check it is working. Well, we're going to turn it off, and it's working now. Okay, let's drive it through 60 centimeter and measure the time now. Alright, there we go. No, I want you to disregard that value. Okay? I was not a good driver this time. I need to drive better. Okay, I'm trying this time to do it better and see if it's going to work. Okay, what is the time you got? You got 0.590. So that will be 0.590. Okay, what I would like you to do now is to use this measurement. Use these measurements, draw a graph of x on the y-axis, time on the x-axis. It'll be very interesting to see how you're going to take the intervals. You see, you got up to 0.59, that's almost 0.6 seconds. So you can go in steps of 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Right? Yes. And on the y-axis or the x values, you go in 10, 20, 30, 40, 50. And then take any 2 points, calculate delta x, delta t, and measure the slope of that graph, and complete the worksheet and email it to me. Okay? Now, these labs are very important. I would like you to take it seriously and work on it. Okay, now that's what I want you to do. Now complete the worksheet and email it to me. Alright, now I'm going to have a second part of lesson 1, study of motion, later on, and I will see you for that a little later. Okay, in the meantime, do this lab and email it to me. Now, in case you have difficulty drawing graph on the computer, remember you can actually do it on a piece of paper and mail it to me. I will give you, my mailing address is actually given in the introduction. Alright, I will see you later.